Okay, welcome to the third week, and in this case, hopefully you've read chapter 3 in the OpenStax, and I want to just as briefly as I can hit the absolute highlights in the first of these PowerPoint lectures that I've left for you. In particular, I want you to see this first view graph, which gives the definition of probability, experiment, outcome, sample space, and event. The probability theory is couched in terms of experiments, where experiments are many different types, maybe almost any type of process or procedure that you go through. The classic ones are pulling cards out of a deck, or rolling die, or tossing coins, or answering surveys. What all of those activities have in common is they have an outcome, or they have a set of outcomes. You answer yes or no to a survey. You roll a 2 when you roll a dice. You pull out a queen of diamonds out of a card. Those all have outcomes. Outcomes are just that, just results of a single trial of a probability experiment. Now there can be a lot of different results, a lot of different outcomes. The collection of all those outcomes is called the sample space, and it's a very important concept, as you'll see in just a few view graphs. An event is distinguished from an outcome. An outcome is often called a simple event. That outcome cannot be broken down any further, as opposed to an event, which can be some collection of outcomes. For instance, rolling a die and rolling a odd number. That event occurs because of the addition of the outcomes rolling a 1, rolling a 3, rolling a 5. So events are nothing more than collections of outcomes. They can also be outcomes as well too. So the next view graph just gives some examples of sample spaces. I think you're probably starting to get the idea. If you roll a die, there's 6 different events that can occur, or 6 different outcomes that occur. 1, 2, 3, 4, 5, 6. If you toss coins, you toss 2 coins. The outcomes could be you get 2 tails, or you get 2 heads, or you get a heads and a tail, or a tail and a heads. So you can see that for each experiment there is a set of outcomes. What you might not appreciate is that the experiments don't have to be too sophisticated before they start to have a lot of outcomes. For instance, in this top chart here, this is the 36 outcomes that occur when you roll 2 die. This below that are the 8 possibilities that you might have in terms of having boys or girls when you're having children, and you have 3 children. So have 3 children, there's 8 outcomes. Roll 2 die, there's 36 outcomes. Roll 3 die, there's 216 outcomes. So you'll see in just a moment that counting the size of the sample space is very important, and can get to be, I'd say it's unwieldy. It's always counting, but you need to find a systemic way oftentimes to do the counting to make sure you don't miss any. That's what those tree diagrams are very useful for. So I wanted you to just capture 2 last things. There are actually 3 types of probability. The book really only focuses, and this course will really only focus on classic probability. I'll let you read the definitions of the other 2. But classic probability is just this. It says that the probability of occurrence of an event is a ratio. On the bottom of the ratio is the total number of outcomes, the size of the sample space. And the top of the ratio is the number of outcomes that make up the event, or that are within the event that you're interested in. Okay, so it's just exactly that. The desirable ways that something can occur versus the total number of ways. This can only make sense to you when you start to do problems and see that in context. And finally, these 4 rules, maybe they're very clear to you, but that you really need to get clear on them if they're not. The probabilities are numbers, decimals, fractions, percentages. that are always between 0 and 1. Can't be bigger than 1, can't be less than 0. 1 means certainty. 0 means improbability. And the last rule is that the sum of all the probabilities of all the outcomes in a sample space is always 1. Meaning, if you run a trial of an experiment, something has to happen. Okay, focus on those rule fundamentals. Make sure you get those down. Actually, as I said, some subset of those, you really have to do some problems to really start to get an appreciation for those things. All right, talk to you soon.